Now let's take a look at how to solve logarithmic equations. So in this problem, we've got 6 plus the natural log of x is equal to 10. Okay, so first thing I'm going to do here is subtract 6 from both sides. So I've got the natural log of x is equal to 4. And then now I'm going to use the definition of a natural log. So when you take the natural log of x, the answer that you get is the power that you raise e to get x. Okay, so recall the definition when you are taking the natural log, that's always base e. So the natural log, oops, the definition is the natural log of x gives you some number. We'll call that number y. And what that means is y is the power that you raise e to get x. Okay, so here, this tells us that x is equal to e to the fourth, and you can actually type this into your calculator to get an approximation. If we take it out to 2 decimal places, so this gives us 0.598, x is approximately 54.60. Okay. Let's look at another example. So here we want to solve for x. So again, first thing I'm going to do is divide both sides by 2 so that this cancels out. And then on the left, I have the natural log of x plus 1 is equal to, and here, since this divides nicely, that gives us 5 on the right-hand side. And again, we're going to use the definition of the natural log of a number. So when we take the natural log of some x plus 1, the answer that we get, which is 5, is the power that we raise e to get x plus 1. So then here, to solve for x, I would subtract 1 from both sides. So e to the fifth minus 1 is equal to x. And again, you can type this into your calculator to get an approximation, and the calculator will give you approximately 147.41. So that's what e to the fifth power minus 1 is equal to. Last example. Okay, so here we want to solve for x again. In this particular problem, notice that you have the natural log on the left and the natural log of some number on the left and the natural log of some number on the right. So again, here we can use the one-to-one property, which tells us that we can set x squared equal to 1. So here, to solve for x, we would take the square root of both sides. And then that gives me x. And then if you take the square root of 1, x is equal to plus or minus 1. So we actually have 2 solutions here. And you can actually check this out by graphing this. So if I graph the natural log of x squared, so let's call that f of x, and then graph the natural log of 1, so let's call this g of x, you'll see that when we actually graph this, so on a graph here, the natural log of 1 is actually equal to 0. So it's actually this line here. So that's g of x. And then when we graph the natural log of x squared, it actually looks like this. So let me put 1, 2 here, negative 1, negative 2 here. That's 0. And that graph actually looks something like this. Okay. So here you can see that our points of intersection occur at x equals negative 1 and x equals positive 1.